This is a vortex tube. A vortex tube is a device that separates compressed air into hot and cold gas streams. It enters through some sort of inlet, not necessarily like this one, but something, so that it enters the tube tangentially. And that makes it swirl around. So since it will be swirling around the outside of the tube, it cannot initially exit the cold end of the tube, which is the end by the blue block. Yeah, right there. It's stopped by the washer. And so it will move along the length of the tube in a spiral-like fashion until it gets to that end. And typically there is a cone-shaped nozzle at that end that allows air to exit only around the outside of the tube. We used a ball valve that works just as well, sort of. So a portion of the air exits out that end, and it is hot. The rest of the air exits out the blue end, and that is cold. Science.
The device works by taking the compressed air that comes into it and swirls it, and basically the hot air is on the outside of the swirl and the cold air goes into the center, and when it hits the diffuser at the end, the hot air has to continue swirling upwards as the cold air gets escaped out. The results we received from this test was about 60 degrees differential, with the cold end at about negative 13 degrees Celsius and the hot end having around 45 degrees Celsius, so giving us around 60 degrees.
There are literally hundreds of research papers that you can find online that talk about vortex tubes. And in all of them, there's something very important to the temperature differential known as the length to diameter ratio. That's the length of the tube to the inner diameter of the tube. Now generally, you would expect to find values around 20, maybe 15 for the maximum temperature difference. Naturally, we decided to use a length to diameter ratio of 75. Somehow this worked better than all of our shorter tubes.
And this is our vortex tube. Thank you. Signing off.